Here's another method for adding carbon chains on the benzene. We use an acyl chloride, and this reaction is nice because here on the end we add exactly the carbon chain that we want, because here there are no opportunities for carbon rearrangements, and we'll see why in a minute. The acyl chloride reacts with aluminum chloride. The aluminum chloride will remove the chlorine and form this ion. Here's another carbocation, like in the alkylation, but this cation is bonded to an oxygen, so it does not have an opportunity for any methyl shifts, because this oxygen is not going to allow that. So it forms this ion, which is in resonance. This is a strong electrophile, so now it just undergoes an electrophilic substitution, forms a sigma complex, and like we saw in the alkylation, this will come and remove the proton and give this product. Now it's important to note that once this product has been reached, it forms a complex with the aluminum like this, bonded to the oxygen. And in order to remove this, we add water and we get this ketone. And I said that this was going to be used for generating carbon chains, and it is. And we'll learn next time how to remove this ketone. There are a lot of different ways some people can do it. But after this ketone is removed, we're left with just the carbon chain. And here, it's easy to see that there are a lot of advantages to this reaction over the alkylation. Firstly, one of the more important ones is that it's easy to get a more precise product because of that rearrangement that can take place in the alkylation to get the most stable carbocation intermediary. We can get a lot of different things happening depending on what it is, but here it's much more precise. You just put the carbon chain you want on there and that's what you're going to get. Another thing that's really nice about this one is once we get this product here, this ketone is an electron withdrawing group. If this were a methyl group, this oxygen weren't here, this would be electron donating. So what will happen is that it's going to activate the ring. And when the ring is activated, it's going to react with more electrophiles. But here, since this is not an activating group, this is a deactivating group, then it's going to be a lot less likely that it's going to react with something else. So while in the alkylation it was possible to get carbon rearrangements and a lot of side reactions or secondary reactions, it's very difficult in the alkylation sometimes just to get one addition, because you're likely to get para and ortho additions as well, because the ring is now more reactive than it was as benzene. If it reacted when it was benzene, it's surely going to react with this group here, this activating group here now. So there are a lot of advantages to the acylation as opposed to the alkylation as far as getting a more precise product.